Hi, everyone. Welcome to Organic Science, a segment curated by The Organic Guy. And with a little help from AI, Organic Science is sharing hidden, hard-to-digest organic and sustainable farming research into bite-sized, brain-friendly insights you can use daily. Today, we're asking, can organic farming feed the world?
Well, the science says yes,
Yelly.
and comfortably so.
Okay, wow. That's a pretty big statement to start us off. What makes you so sure?
We've been digging into this really fascinating study. It's a 2007 paper published in Renewable Agriculture and Food Systems
Okay.
titled Organic Agriculture and the Global Food Supply. And it's from researchers at the University of Michigan and Michigan State University.
Right, so top universities tackling this huge question. What were the sort of main things they were looking at?
They were really getting into two of the biggest knocks against organic farming you always hear.
Yeah.
First, this idea that the yields, how much food you get per acre are just way lower than conventional farming.
Right, the productivity argument. That's number one, always.
Exactly.
Yeah.
And second, the question of fertilizer. Like, can we even get enough fertilizer that's okay for organic rules to feed everybody?
Okay, those are definitely the two heavy hitters.
Okay.
So how did they test these ideas?
Well, they did a couple of big things. They gathered a massive global data set. We're talking almost 300 examples.
Wow.
Comparing yields, organic farms versus conventional or sometimes low-intensity farms all over the world.
So real-world comparisons.
Yep. And then they specifically looked at nitrogen, which is super important for plant growth. They calculated how much nitrogen could be naturally captured from the air by planting things like beans or clover, leguminous cover crops, and adding it to the soil.
Ah, using nature's own fertilizer system.
Yeah.
Okay, so our mission for this deep dive then is to really get into this evidence. Let's see if those old assumptions about organic limits actually, well, hold up.
Precisely. Let's start with that yield question first. That seems like the biggest hurdle in most people's minds.
Definitely. So what did all that data show when they compared organic yields to the others?
Okay, let's unpack this. It gets interesting when you split the results. In developed countries, wealthier nations,
Yeah.
for most food types, think grains like wheat, starchy stuff like potatoes, veggies. The average organic yield was, a little bit lower than conventional. The ratio was just under 1.0, meaning slightly less yield on average.
Okay, so in places like the US or Europe, the common idea holds a bit of water. Right. Organic yields can be slightly lower.
On average, for many common crops, yes. But here's where it gets really interesting. When they looked at the data from developing countries, the story completely flipped.
Flipped out.
For many of the same categories, grains, roots, legumes, organic methods actually produced more food on average than the existing local practices. The yield ratios were often greater than 1.0.
Whoa, okay, so in large parts of the world, organic farming wasn't just comparable, it was better in terms of yield.
Exactly. That's a huge finding. It really challenges that simple organic means less food narrative.
This is why the difference. Why higher yields there?
It's all about the comparison point. See, in many developing regions, organic wasn't being compared to super high-tech, high-input industrial farms.
Right.
It was often compared to traditional, sometimes resource-poor subsistence farming. So bringing in organic techniques, things like composting, cover cropping, planned rotations, that was actually a step up. It was an intensification, improving how things were done.
That makes perfect sense. So organic in that context meant better farming leading to more food. Okay, so the study didn't just compare yields. It then tried to model a global organic food system.
Yeah, they built two global models to estimate what the total food supply could look like if everything went organic.
Okay, what were the two approaches?
Model 1 was pretty conservative. It basically took those slightly lower yield ratios they found in developed countries and applied them everywhere, across the whole world's farmland. Kind of a worst-case scenario, maybe.
Right, assuming the developed world pattern was universal. What did that model show? Could we still feed everyone?
Amazingly, yes. Even with those lower yield assumptions, Model 1 estimated that global organic production could provide enough food per person to feed the current population.
Wow.
Things like grains, sweeteners, meat, milk production levels looked pretty similar to what we have now. Some things like starchy roots and legumes were estimated a bit lower, but overall.
Still enough food globally. Okay, that's pretty compelling even for the cautious model.
Yeah.
What about Model 2?
Model 2 is more nuanced. It used the developed country yield ratios for developed countries, but it used the developing country yield ratios, remember, often higher for developing countries.
Okay, so it reflected the reality that organic can actually boost yields in many places.
Exactly. And the results from that model were, well, pretty stunning.
How stunning.
So what does this all mean? Model 2 didn't just show enough food, it estimated that a global organic system could produce significantly more food than we currently do, in nearly every category.
More. Like how much more?
Often over 50% more across the board. For grains, which are obviously critical, the estimate was 145% of current production levels.
145%.
Yep. A huge potential increase, according to that model.
That completely reframes the debate, doesn't it? If that model is closer to reality. What about calories? Did they look at sheer energy availability?
They did. Current global average food supply is about 2,786 kilocalories per person per day.
Okay.
Model 1, the cautious one, still delivered 2641 kilocal, which is well within the healthy range for adults usually pegged around 2,200, 2,500 kilocal.
Right, it's still plenty.
But Model 2, the region-specific one, it projected a massive 4,381 kilocal per person per day.
Goodness. Nearly double the requirement. So lack of calories really doesn't seem to be the issue under either scenario.
Not according to this study, no.
You mentioned those higher yields in developing countries often came from intensive agroecological techniques. Can you unpack that a bit? What kind of techniques are we talking about?
Sure, it's not just about not using chemicals. It's about actively managing the farm ecosystem. Things like smart crop rotations, definitely using those nitrogen-fixing cover crops we mentioned.
Right.
Integrating trees, like in agroforestry systems, using compost and manure really effectively, managing water carefully. They even mentioned the system of rice intensification, SRI.
SRI.
It's a set of practices for growing rice, managing water, plants, soil, and nutrients differently. And in some cases, these kinds of intensive organic methods used in SRI have actually beaten conventional rice yields.
Really?
Yeah, though the paper acknowledges there's still some debate about just how high SRI yields can consistently go, but it shows the potential of these integrated knowledge-based approaches.
It definitely sounds like more than just letting nature take its course. It's active, smart management. You also touched on crop rotations being different in organic systems. How does that make comparing yields tricky?
Yeah, that's a fair point they raise. Organic systems often rely on longer, more diverse rotations. Maybe you grow corn one year, then beans the next to build nitrogen, then maybe wheat.
Right, building soil health over time.
Exactly. Whereas conventional might be corn year after year, or a much simpler rotation, relying on synthetic inputs. So comparing the yield of just one crop in one year doesn't always capture the whole picture or the long-term benefits.
Makes sense. You're comparing parts of different systems.
Right. But even with that complexity, the study concluded that overall you could still produce enough grain and other staples organically.
Okay, so the yield argument seems, well, much more complex and potentially much more positive for organic than usually presented. Let's switch gears to the other big one, fertilizer, specifically nitrogen. Is there enough?
Right, nitrogen. It's often the main nutrient that limits crop growth. So the study really zeroed in on those leguminous cover crops, again, the beans, the clover, alfalfa, plants like that.
The ones that make their own nitrogen from the air.
Precisely. They act like little on-farm fertilizer factories. The researchers calculated the global potential for nitrogen fixation just from these cover crops.
And the number was?
Get this, around 140 million metric tons of nitrogen per year. Globally.
140 million. How does that compare to what we use now in synthetic fertilizer?
Current global use of synthetic nitrogen fertilizer is about 82 million metric tons a year.
So, wait, the potential from cover crops alone is more than we currently use synthetically.
By a lot. About 58 million metric tons more. Potential excess.
Wow.
And that's before you even count other organic nitrogen sources like animal manure, compost, or other nitrogen-fixing techniques.
That's incredible. So the argument that there just isn't enough organic nitrogen seems, well, flawed according to this.
Based on these calculations, yes. They even showed that in a high-use country like the U.S., cover crops could potentially supply more nitrogen than is currently used synthetically.
And this cover cropping practice, it does other good things too, right? Like for the soil.
Absolutely. Helps prevent erosion, builds organic matter, improves water retention. Lots of benefits besides the nitrogen.
Did they estimate how much nitrogen you could expect per area?
Yeah, the global average potential worked out to about 103 kilograms of nitrogen per hectare per year.
Mm.
A bit more in the tropics, a bit less in temperate zones, but a significant amount either way.
And is this organic nitrogen different from synthetic? Does it work better or?
It often behaves differently in the soil. Organic nitrogen usually gets released more slowly as soil microbes break down the plant material.
Okay.
That can be an advantage because it feeds the crop more steadily over the growing season rather than a big hit all at once. And it helps build up that crucial soil organic matter over time, improving soil health.
So it's not just about quantity, but also quality and timing of release.
Right. And again, that 140 million ton number, that was likely an underestimate.
Why is that?
Because they only calculated for cover crops used as green manures, basically grown and then plowed in,
Mm.
they didn't include nitrogen fixed by legumes grown as a main crop or intercropped legumes grown alongside other plants,
Ah.
or nitrogen from livestock manure in integrated systems, or from nitrogen-fixing trees, or even free-living microbes in healthy soil. The true biological potential is probably much higher.
It paints a very different picture of fertility management, focusing on cycles and biology instead of just bags of synthetic stuff.
Exactly. It's about nurturing the whole system. Plus, healthier soils and organic systems can sometimes help plants use the available nitrogen more efficiently, too.
Okay, so taking both the yield findings and this nitrogen potential together,
Mm.
what's the big takeaway about the overall feasibility of feeding the world organically?
The study's main conclusion is pretty clear. Organic methods have the potential to contribute substantially to feeding the current and likely future population. And importantly, doing it on the existing farmland base while maintaining or even improving soil fertility for the long haul.
So, not just possible, but potentially more sustainable.
That's the implication. They even suggest that widespread organic adoption might allow us to reduce the total amount of land needed for farming eventually, though they do note conventional intensification in the tropics could potentially do that too.
And you mentioned earlier that the way yields are measured might even underestimate organic potential sometimes.
Right, because many organic farms use polycultures growing multiple crops together. Think like corn, beans, and squash all in the same field.
Yeah, the three sisters.
Exactly. Those systems can have a much higher total food output per acre than just growing corn alone. But if you only measure the corn yield, it doesn't look as impressive. Standard yield data doesn't always capture that whole system productivity.
That's a really good point. And what about research focus?
Ah, yes. They point out, quite rightly, that for decades, the vast majority of agricultural research money and brainpower has gone into optimizing conventional high-input systems.
Makes sense.
Imagine if the same level of sustained effort went into optimizing organic and agroecological methods. We could likely see even greater improvements in yields and efficiency. There's still so much potential to unlock.
It also seems like organic might align well with smaller farms, which often have higher output per area anyway.
That's another connection, yeah. And while organic farming often does require more labor, more hands-on work,
Which is often seen as a downside.
right, but in many parts of the world with rural underemployment, that could actually be a huge positive, creating meaningful work, boosting local economies.
Turning a perceived negative into a potential positive. And of course, there are the environmental aspects.
Absolutely. The study implicitly contrasts this potential with the known environmental costs of the Green Revolution style of agriculture. Soil degradation, water pollution, reliance on fossil fuels for fertilizers, greenhouse gas emissions. Organic offers a pathway that seems much more aligned with long-term environmental health.
But it's not like flipping a switch, right? Transitioning the whole world to organic would have challenges.
Oh, for sure. The study acknowledges that. There would be huge agronomic hurdles. Farmers needing new skills, different equipment maybe, economic challenges, especially during the transition years before the soil benefits fully kick in.
Right, the transition period can be tough.
And you'd need massive investment in education, farmer training, extension services, getting that knowledge out there, plus supportive government policies, research funding. It's a big shift.
So it requires a systemic effort, not just individual farmers changing.
Definitely. But the core message from this research seems to be that the conversation needs to shift.
How so?
It suggests the question isn't really if organic can feed the world anymore. The evidence here says it likely can. The real questions now are, how do we best implement these agroecological approaches? How do we support farmers? How do we overcome those transition challenges?
Focusing on the how, not the if.
Exactly. And remembering, as they point out, that how we produce food is just one piece. A truly sustainable food system also needs to address economic fairness for farmers access to land, water issues, what people choose to eat, poverty. It's all connected.
That's great points, the whole system. So for you, our listener, wrapping this up, what's the single most important idea to take away from this deep dive?
I think the key thing is realizing that organic farming isn't just some small niche market for wealthy countries. This science, from back in 2007 even, showed pretty convincingly that it has real large-scale potential to feed the planet.
And in many cases, potentially better than existing methods, especially considering sustainability.
Right. It challenges that fundamental assumption that we must rely solely on industrial, chemical-intensive agriculture to avoid starvation. The data suggests there's another viable and potentially more resilient path.
Okay, a powerful shift in perspective indeed. So here's something for you to chew on. Given this scientific evidence suggesting organic can feed the world, what do you think are the real roadblocks stopping it from happening more widely? Is it economics, politics, habit, lack of knowledge? And maybe think about what role you personally could play in supporting a food system that's maybe a bit more sustainable, something to consider.